Okay, welcome to Unit 4, Day 2. This is Part 2 where we'll talk about types of bonds and properties. Specifically, we're going to focus on metallic bonds. And you're going to, for the first half, take notes in Section B of your note packet. So this unit is about bonds, and there are 4 types of bonds. We're only going to focus on 3, but let's just list the 4 types. There are metallic bonds, molecular covalent bonds, ionic bonds, and network covalent bonds, which are actually the bonds that are in diamond, graphite, and some other things like silica. We will not learn about network covalent bonds here, but you might want to, as an extension, do a reading on network covalent bonds. So these are the 3 types of bonds we're going to focus on for this unit. And in this video, we're specifically going to focus on metallic bonds. Now, in Unit 3, we already looked at properties of metals. And in this unit, what we're going to do is we're going to explore that a little bit further. By learning about metallic bonds, it will help us to better understand properties, those properties of metals that we learned about previously. So, first of all, how do you identify if something is a metal? The key thing is it has to contain metal atoms only. So this would be a good time to pause and write that down in your chart in Part B, where it talks about the types of atoms. So if it contains metal atoms only, it's a metal. Examples of that would be something like iron, copper, and then another example here, we have a mixture of copper and zinc, which is colloquially known as brass. And so when you have a mixture of different metals, like an example like brass, those are called alloys, but it's still a metal. And in fact, the gold, in quotes, penny that we made earlier was actually a brass penny. So what we did is we mixed the copper with the zinc to create brass. And brass kind of looks like gold, but it's not gold. It's an alloy of copper. So just to quickly recap, if you want to identify if something is a metal, you have to look on your periodic table and make sure that the atoms in that substance only contain metal atoms. So if there's only metal atoms, it's a metal. All right, so what do the bonds that hold metal atoms together look like? Well, what we use is what's called the sea of electron model. So the sea of electron model, it's used to describe metallic bonding. And the way that we like to think about it is that the metal cation is in a sea of its valence electrons. And the valence electrons, they're not attached to one metal in particular. They sort of flow like a fluid. So, and that leads to some very interesting properties, which we'll see later. So let's take a look at an example of a lithium atom. Lithium has 3 protons, so its nucleus has a +3 charge in the middle. And then it has, if it's neutral, it would have a total of 3 electrons. The first 2 electrons are the inner electrons shown here in yellow. And then you have the valence or outer shell electrons shown here in green. So in a metallic bond, the nucleus and the inner electrons, which are represented by the yellow circles with the plus charge, are being surrounded by these valence electrons. And if you notice, the valence electrons are not staying still. They're sort of moving all around. And so the lithium cation sort of can flow in that. Now, just to remind us of what these properties are before we go into how metallic bonding explains those properties, here are some properties of metals that we already know. First of all, most of them are solid, the exception being mercury. They're mostly gray or silver in color. And that's if it's an element. If it's a mixture, like we saw with brass or bronze or some other things, they'll have different colors as well. They can be like more goldish or brownish color. Metals we also know are shiny. And many metals, not all, but many of them are good conductors. And remember, a conductor is something that if you use it to connect a circuit, it will connect that and complete the circuit, allowing charge to flow through. They're also malleable, meaning that you can bend them and they won't break, they'll just bend. They have high melting points and high boiling points, so many of them it requires a lot of heat to melt them into a liquid or to boil them into a gas. They are also insoluble, so if you take a piece of metal and you put it in water, it's not going to dissolve. Some metals will react with the water, but they will not dissolve. And finally, many metals are hard. The exceptions are the alkali and alkaline earth metals. And remember, that would be the group 1 and group 2 metals. So with the exception of group 1 and group 2, most metals are hard. All right, so in this next section now, we are going to use metallic bonding to explain some properties. This will be taken in note section C. For honor chemistry, this is required for you to take these notes. For fundamental chemistry, it's optional for you to take the notes, but you must watch this video. Okay, so let's look at the properties of metals explained by the sea of electrons. First property we're going to look at is good conductors. So how does the bonding of metals explain why many metals are good conductors? The main thing is, in order for something to be a conductor of electricity, it must have mobile or movable charges. And that can be an ion, or it can be electrons, or whatever, that can complete the circuit. And for metals, the movable charges are the electrons in the sea of electrons. Remember, those valence electrons are not attached onto the atom. They sort of flow around. And so as a result, it allows metals to be conductors. The next property is malleability. As we know, metals, if you hit them, they're going to dent, or if you bend them, they're going to bend, they're not going to break. So metals are not brittle, they're malleable. And so why is that? That's because if you take a look here, this image here, if you hit the metal, so let's wait for it to hit the metal. Notice how the atoms will sort of shift down, the cations will shift down inside that sea of electrons. And those sea of electrons, because they flow and they allow the metal cations to sort of move within that, the bonds don't become broken, but you can shift them. So you can shift the metal cations without breaking them. The last property we're going to talk about are the high melting point and the hardness of metals. So many metals are hard, many metals have high melting point. Why is that? It's because if you look at the metallic bonds, they're sort of arranged in a lattice or a network. You can sort of think of it as if you sort of draw lines through the cations, connecting them, they have this network arrangement. And in between each cation, you have the sea of electrons sort of holding those metal cations together. So because they're arranged in a network or a lattice, that sort of strengthens or reinforces their bonds. You're not just breaking apart two metal cations, you would have to break apart a lot of them. And so because of that, it takes a lot of energy to separate the atoms in this molecule or in this substance. And as a result, they have high melting and boiling points, and many are hard. So this should say separate atoms, by the way. And you can take a look at some of their melting points. So this column here is in Fahrenheit, which scientists typically don't look at. So let's focus on the Celsius. You will see here that the melting points of metals are, in the high hundreds or in the thousands of degrees Celsius. All right, so they have really high melting points because of their bonding. Okay, so that is it for this video. So what you want to do now is we're going to go into ionic bondings next. So that's it for this.